And hello, welcome to today's code exploration of SpiceSharp. Okay, the last time we were stuck with the question, how are variable maps constructed? Okay, reminder that variable maps are dictionaries or key value pairs, or rather variable and integer pairs that give specific variables in the matrix. For example, you have this x1, x2, x3. All of these are the variables you're talking about. Of course, all of these have to be indexed by certain integers. So how do you automate the construction of that during the setup of the simulation? Okay, so I did some coding exploration as before. Okay, so there are a few places to look, so I will walk you through my thought process. Okay, over here you actually put in all the data. You see, we actually put in data for what the name of the voltage source is, for example. So these are called entities. Components are entities, they inherit from the entity class. Okay, voltage source is an entity. Okay, so this is V1. Voltage source V1 is connected to the in port, and it's also connected to the 0 port. So this is the in port and this is the 0 port. Positive node, negative node. Resistor R1 has a positive node at the in. Here is in and out over here. So so these are how you kind of notify that, hey, these nodes, these are called nodes. These are nodes of interest. You want to do a summation of currents over them. You want to do a current conservation over them, and therefore you build equations around them, and you want to know what the voltages at these points are. Okay, that is the point. Okay, how do you construct this? Okay, so we can either look at the circuit. Okay, first place we look is the circuit class. Okay, the circuit class is over here. Again, it's an IEntityCollection, so it's just a collection of entities that doesn't really do anything, except that when you supply it with an IEnumerable of entities, right? IEnumerable of entities, or parameter. You load it with multiple entities using the params keyword. So params means you can enter as many of IEntity as possible. So params IEntity means to say you can enter as many entities as you want, and all of this will be formed into a IEnumerable of sorts, an IList. Okay, or rather this all will be formed into an array which implements the IList interface, and that's why there is this for each. Says what, for each entity in this entities list, okay, you add the entity. Okay, why can you use this add? Because this circuit actually inherits from IEntityCollection, which probably inherits from iCollection as well. Okay, or rather, circuit does not inherit IEntityCollection. Circuit actually implements IEntityCollection. So there should be an add method here. So you see, add entity item. There's a lambda function for the entities to add the item. So what is this entities object? There's an IEntityCollection called entities. Okay, IEntityCollection called entities. Okay, so circuit and this IEntityCollection, these entities, actually both of them, they fulfill the IEntityCollection interface, implement rather. So yeah, I do not see any other like constructor here. Okay, all of them you actually need to put in an IEntityCollection of entities, or where's the params thing? Yeah, you actually put the params thing here. This params thing again implements actually gives in an array which definitely will fulfill the IEntityCollection or IEnumerable collection interface. IEnumerable or IEntityCollection interface. See, it inherits from IEnumerable, iCollection, or iClonable. So it either inherits or implements, but there are many of those there, so that's okay. Yeah, so that's what you have right there. Okay, so what am I saying here? Okay, yeah, based on this constructor, you actually just give a number of entities in here. So what are these entities? Voltage source, resistor. All of these are entities. So you're passing in multiple of these as the arguments. And what happens after that? Yeah, what happens? Oh, shoot. Yeah. What happens? What happens after that is that this array is formed, and then yeah, this array is formed, and then you start adding it to this what do you call that? Oh, rather, pardon me. Okay, when you start the circuit constructor, okay, you create this array of entities by passing in multiple entities as the argument. Okay, the base constructor is called because you actually call this, okay, this. So this here is actually the base constructor, which is the constructor which actually has no argument supplied. So you see the no argument supplied constructor is this circuit, okay, and then you'll say what entities equals to new entity collection. So this is just a collection of entities. This entity collection actually fulfills or implements this IEntityCollection interface, and then it will put it into this private read-only variable. And then once you do that, you can start what do you call it? Yeah, you can start adding what do you call that? Yeah, once we initiate that, we can start adding the entities to this entity collection, and that's all it does. There's nothing more that's being done here. You don't see any code here dealing with VariableMap. So we can sort of guess that this circuit doesn't really do anything with the variable maps. So no variable maps here, so we won't look here just yet. So what are the other places that potentially deal with variable maps? Okay, this will be, then we'll have to look at the entities themselves. Okay, you can look at the positive and negative strings. Where are they being fed into? What's actually going on here? Yeah, what's actually going on here? Okay, the connect method is being run. Okay, so anyway, let me just write that down before I forget. Okay, the connect method. Oh, okay. I did write down some, just forgot to compile. Okay, so there's the connect method that's being used. See, the connect method is being used, and the connect method is actually inherited from component. Yeah, because if you take a look at the resistor, and you try to find Control F, or you try to find connect. So you cannot find anything for connect here except, yeah, these two lines of code. Okay, this line and this line. You try to Control F, you cannot find connect here. Where is this function, or where is this method being defined? Okay, you'll not find it here, so you might want to take a look. You might want to take a look at where resistor inherits all its functions from. Resistor actually inherits its functions from component. Okay, component here has the connect method right here. Okay, what does connect method do? It will take in params. Okay, params keyword means to say you can supply multiple values of these strings. You can supply multiple strings into this this thing, this what do you call that, nodes here. You can supply multiple strings into this function. It will compile all those strings into an array, and then you start doing stuff with the array. So this one is the if connections equals to null. Okay, so this is just code to help you check for exceptions. So this is just to help you check for exceptions. The main bulk of the code, the original purpose of the code, how it's intended to function, it's over here. Okay, for var I equals to 0, blah blah blah, all of this is a for loop. Okay, what happens here is that, okay, it says what, throw if null. So this is another guard to say if the nodes have null values, it will throw throw an exception. So that's always a safeguard there. So you can see a lot of exceptions are being thrown, which is a good thing, good coding practice, so that you know that if you supply input that's not meant to be put in, then you will start having a lot of exceptions, which is good. Okay, so what's the main thing here? Connections at the ith index will be equals to nodes at I index. Remember nodes here is actually an array of string. Okay, so nodes here is an array of string. So the array of strings will be you can actually you will actually be loading these string values into the connections thing. Okay, where is connections being done? Okay, connections here is a private array of strings. Okay, connections here is actually a private array of strings, and yeah, that's the only thing you'll do when you start putting things into connect. Yeah, you put things into the connections. I mean, yeah, you put strings, you name your nodes that you're connected to, and you actually put it into the connections. Then this component will have a private string of connections which says which nodes am I connected to. Okay, then how do you access these connections? Because it's private, right? The only way to access the connections variable is using this function here, or this method here, which is a lambda method. Okay, lambda method, it says I read only list nodes equals to new read only collection. So this is a collection of read only things. Inside this collection there are strings, and the strings the connection of strings are basically this connection here, this string array here, and that's the only way you access these connections, or access the nodes that are over here, right? The nodes that are over here. So okay, the connect method just populates the connections private variable. Okay, where is this private variable? This is line 21 in components.cs. Okay, as of May 2022. So it just populates it here, and if you want to access the connections private variable, what do? Okay, the thing is that you call the nodes method within the entity or component. Okay, you call the nodes method within the entity and component, and what it will do is that it will return a read-only list of strings which are names of the nodes. Okay, so all the while now we are just dealing with strings. We are not making any new objects just yet. So that's what this read-only list nodes will do. So it's very important that we start looking here. Okay, so the resistor class actually inherits from components class. Okay, the connect method just populates the private let's see. Connect method is inherited from component line 42 to 60. Yeah, so that's what this part here is, and all it does is just to populate the connections private variable. If you want to access the connections private variable, you call the nodes method. Okay, again here, the nodes method is right here, and what that will do is that it will return you a read-only collection of strings, or read-only list of strings. So nothing too exciting here is happening. I do not see any variable map being populated, so we'll have to look elsewhere. Okay, so that's already checking off 2 points. Okay, we don't see the variable map being constructed in circuit. We do not see it constructed in the resistor. So no reason, probably no reason to see constructed within voltage source, because what we expect is that both of these will behave very similarly, in the sense that both of them inherit from component, and component doesn't do anything with the connect method, except to say I'm just populating a list of this. I'm populating a list of nodes right here. Okay, see, these nodes here are read-only collection. Okay, so since we do not see variable map being played around with here, we will then need to look at other places. Okay, so we'll need to look at this maybe DC class, because this we already analyzed this part. We do not see any map building here. The variable map is not being built here. So next place to look is at this line of code, where we actually initiate a new DC simulation. So this is a DC simulation. So I'll say next place to look for where variable maps is constructed is, what is this place? DC simulation. Okay, because I'm looking at the this example. Okay, I'm looking at the getting started example. All right. Yeah, I want to use Vim. Okay, so anyway, so what's the next place to look? This is the DC part. Okay, so where's the DC? Okay, let's take a look at the DC simulation. Okay, DC simulations are actually under spiceSharp simulations implementations, and go to DC. Okay, so DC is here. Okay, the DC simulation code is found here. Okay, I'm going to put the URL. So this is where you'll find the DC part, spiceSharp simulations implementations, DC. Okay. All right. So that's the place you will find it. Okay. Right. So let's take a look at the DC.cs, and this should be our main place we actually look for the where we actually look for variable map. So let's search for variable map here. Okay, we will not see any variable map here. We will see a lot of other code such as what? There's this execute thing. Okay, there's a constructor that looks for the circuit name. Okay, it names the name of the circuit. Alright, it names the name of the circuit. Okay, so let's take a look here. Okay, it names the name of the circuit, which is DC1. Then you supply some things here. Okay. Okay, so this part is actually just to catch the exported simulation data. But again, we don't really. These are just to help us to see where are the important points where we want to take note of the voltage, the input and output voltage. All right, so we actually look at the input and output or nodes or something like that. So okay, so what's the DC constructor like? There's the DC1 simulation name. Okay, simulation name, and yeah, this is the constructor here. This is also another constructor, which is this is the constructor that has name, string source, double start, double stop, double step. So this is a DC sweep. At which point, which node do we kind of start our DC sweep? Okay, at which node do we vary the voltage so that we can check the other points of voltage? Okay, so that's what the DC sweep is about. Okay, we actually check the component V1. Okay, that means we change the V1 voltage source, and we alter it from -1 to 1. Okay, so this one looks like we are just altering the voltage source, nothing more than that. Okay, so this source is a string, so you need to give it the name of the voltage source that you want to alternate, restart, stop, and everything. So again, no variable map is being constructed here, so we have to look at the next line of code. Okay, we have to look the next line of code somewhere. And so this one has to deal with exported data. That's usually a post-processing thing. No reason for us to expect that, you know, our initial matrices will be constructed there. What is really interesting here is that we have this circuit object. Okay, so this circuit object will be loaded into this DC object, and then you'll just have this run. Okay, we will just run. Okay, a lot of things are going on in this one line of code, this run code here. So what's actually being, where is the run code being run from? Okay, where's the run code being run from? So if we try to Control F and let's take a look, we try to find the run method, we will not find it here. The place to look then is in the biasing simulation code. Okay, biasing simulation, you'll see that it's under simulations based biasing simulation iteration state, simulation state, and biasing simulation.cs. You'll see that all these are partial classes. Oops. You see that all these are partial classes, meaning to say that they are never called on their own. Okay, they are always they are abstract classes, which means they are never meant to be instantiated on their own, but they are meant to be inherited by some other class and then run from there. Next thing is that it's a partial class. As you can see, this class is actually being broken up into 3 files so that it makes the reading easier on the eyes for the programmer, makes the code a bit nicer to read. Okay, well organized. Okay, so after some check, so what do we look at? We look at the constructor of the DC simulation. Okay, no information of nodes is supplied here. The only place we supply information to the DC simulation object is in the line. Okay, I'll put the verbatim here, dc.run ckt. Okay, DC run circuit. Okay, so DC run circuit is where a lot of the things start. So where is the run method? Okay, so where is the run method? Okay, oh, it's the run with the capital R, so I'll just put a capital R here. Where's the run method? Okay, we want to look at the inherited or parent or base classes where DC inherits from. So where are the classes that DC inherits from? So there are 3. It inherits from biasing simulation. DC inherits from biasing simulation. Biasing simulation is split into 3 files, partial classes, and is not meant to be instantiated on its own. This is an abstract class. Okay, so that's over here. Let's take a look. So I'm going to put all these 3 inside here. Begin, itemize, item, URL here. So these are the 3 places you'll find it. Item, URL here, and last one, item, URL here. Okay, let's see whether this compiles. So while this is compiling, I want to take a look at this. Okay, first thing is this iteration state. Okay, biasing simulation partial classes. Okay, so I'll just put the link here. So these are the biasing simulation partial classes. It may change in future, I don't know, but here is where it is now at the time of the creation of this video. Okay, so you see this public abstract partial class biasing simulation. It has a nested class here. One of the nested classes, one of the classes within this class is called iteration state. Okay, it has a protected access modifier. Okay, this iteration state will just tell you what is the iteration mode, what's the source factor, what is gmin, what is convergent. Okay, all of these things are over here. You'll not touch them. Again, we don't see variable map here. Okay, second part is biasing simulation state. Okay, the simulation state is yet another nested class within the biasing simulation class. So there are two nested classes so far within the biasing simulation class based on our exploration. Okay, here we start seeing some things that are quite interesting. Okay, look here. Variable map is a read-only property. Okay, so I can put here under simulation state. Okay, we see variable map appear for the first time in our code exploration. Okay, so there's a variable map here, there are vectors here, old solution, new solution, and then this map method. The map method accesses the variable map using a lambda function. So this is the lambda function that just accesses this private variable map. Okay, and oh look, we have a pivoting solver here. So the sparse pivoting solver is actually put here into the one of the public variables. Okay, so moving on, we see that this simulation state class has a lot of all of this here. Okay, so variable map appears for the first time in our code exploration under the simulation state nested class. Okay, so this is a simulation state nested class. It has all of these things here, and that's basically this whole class here. This whole class here is the simulation state nested class. It's a private class. Okay, it will inherit from some variable dictionary. I do not know what that is now, but it implements the biasing simulation state. So this is very important. biasing simulation state, we've seen that being used here, and then the map method is being accessed from this very class. Okay, so what's with this simulation state here? You can see that in the constructor here. Okay, you can see that in the constructor here, we actually need to inject in a solver and a comparer. Okay, but no matter, the solver is important because it contains, I think, most of the equations here. Yeah, it should contain the equations for the equations and methods for manipulating the equations, but that's not where we start our variable map. Okay, where we start our variable map is right over here. Okay, map equals to new variable map using the ground variable, and this ground variable is a new solver variable that injects this the instance of this very class. Okay, constants.ground 0 units.volt. So this is the ground part. So ground is this 0. Ground is 0. Okay, where you see these three lines here, this is 0 volts. That is the ground. Okay, that's basically, if you talk about ordinary differential equations or partial differential equations, this is a boundary condition of sorts. I mean, essentially it carries that meaning. It may not be the exact same thing, but essentially it carries the meaning that, okay, the voltage there will always be fixed at 0 volts no matter what happens. Okay, so this is a new solver variable. Okay, then we can write this down in simulation state constructor. a new solver variable called GND ground, which is basically our ground, is constructed and loaded into a newly instantiated variable map. Yeah. So at least that's what this constructor here seems to be doing. Okay. So that's what is happening here. And then every time we actually create this private variable, okay, we are also allowed to add new results, new things to we are actually allowed to connect new things to this begin verbatim, we'll put here. So besides adding the ground variable to the new variable map, we also use the CreatePrivateVariableMethod within the simulation state to construct the variable map. Okay, so this is important. Once we start constructing the variable map, okay, once we start constructing the variable map, oh, these things need a very good indent work. Okay, let me indent them properly. Unfortunately, this is not Vim, so I cannot indent everything all at once. Okay, so the first variable, okay, the first variable to be put here. Okay, let's just make some notes. The first variable to be put in here is the ground variable, followed by whatever variables we make using CreatePrivateVariable. Okay, so this actually returns us the private variable, but it does more than that. It actually adds the name, the result, everything here. Okay, so so this actually creates all the private variables. Okay, or you can also and every time we make a shared variable, we also call the CreatePrivateVariableMethod. Okay, so this is something we can look at later. But you take a look. So the over here. Okay, so anyway, just want to say that this part of the code is important to look at for matrix construction. Okay, these are the methods that are being used. Okay, in the simulation state, here the methods are being used to help you construct the matrix. Okay, help you construct the matrix. So this is important. Okay, simulation state plays an important role in matrix construction by naming or by constructing the variable map. Okay, so this thing I'll stop now, and I will just maybe continue next time. Okay, yeah, so these are methods to construct variable map. I'll stop the video now. I'll call it a day. I'll probably need to get some rest. Okay, thanks for watching.